So we're going to be looking at, again, the Unit 1 in Matter and Measurement, and finishing off the topic of measurement today, mainly talking about the converting or those types of problems that we will look at. Another way of saying converting is saying dimension analysis. It's a way of doing calculations so that it provides that very systematic way of solving problems. It's a way to check to make sure that you have the correct units that you need as you're kind of going through that process, the checking of the results, results canceling out, or the labels canceling out so that they equal to 1. That's usually the part of that. It's an important part of it is mainly the per expression. We don't have the correct per expression, and it can be done there. And a lot of times we're going to write it as a fraction. And how that is written as a fraction can be, it doesn't really matter how. Some people will write them as fractions, say 1 inch as 2.54 centimeters. That's not how I prefer. I prefer doing it a little bit more neater, I think, is 2.54 centimeters, written it that way. I've even seen the railroad tracks method being used where, again, you're utilizing from some similar properties of these. A lot of you have probably been taught how to do conversions or dimension analysis in other classes. Whatever method you use to get the right answer is really up to you. I use a system that works for me. I've found that it has success for other students, so that's why I use it. There are other methods. I'm aware of them, but that's why we show our work on our problems, so that if you do run into a problem, that you can see maybe where that issue is at. And so we'll kind of go through some of that as we continue on with the class. Ultimately, you set up these systems like this using this conversion factor. Your given unit is on the bottom, so that it would cancel out or become 1. The desired unit can be done there. Now, sometimes the desired unit isn't actually done right away. Sometimes you have to convert multiple things to get to that one item. That's sometimes frustrating for people. However, I think that it is something that we do need to work at and continue to do, so that we have those little systems set up and are also in place, so that we can make sure that we're doing it step by step and not skipping too many steps. And I think that's where we get into this and get into a problem in converting or dimension analysis, is trying to skip too many steps. And we need to make sure that we are able to do things very systematically. It might seem slow and mundane. However, it is best that those things get done correctly as we go through. So I think the best way to start a lot of converting is actually doing converting problems. The mass of an electron is seen as 9.109 times 10 to the negative 31 kilograms. Now express that mass in micrograms. That's skipping some steps. I always prefer sometimes, especially when starting out, that we kind of step and go, okay, I'm starting at kilograms. I need to go to the base unit of grams, and then I will know the converting factor into micrograms. So it's doing the step that you need. And so that's where it is. I've even seen students then come in and say, there'll be 1,000, and then it will be 1 million as the conversion factors. Now, we then need to figure out where they go. And that's where, again, dimension analysis, I believe, helps us out a bunch, and that we can do some of that. And so I'll start with my given, and that's always how we start our conversion problems, with a given. It is good practice to write the scientific notation in there, and it should be negative. Writing your labels in, and then now going to the next one. I want kilograms on the bottom, and I want grams on top. Now, I ask myself the question, which is bigger, grams or kilograms? If you're the biggest, strongest, you're usually number 1. And then it's okay, then how many grams are there in 1 kilogram? There is 1,000. Now, we then can say by the power of algebra, those cancel out, or ratio out to 1. Either way, either method or way of saying it is pretty close to the same. We then see, okay, now I have grams, because I look up here and I go, I'm here, now I need to go here. Now my desired unit is going to be micrograms, and I want to get rid of, or my given unit is now grams. We can then identify which one is bigger, and that would be a gram. Micro just already sounds small. Well, how many micrograms are there in 1 gram? That is where 1 million comes into play. And so there we have that. And so we're multiplying across the top, and we're actually moving the decimal place in the positive direction. And we're moving it 9 times in the positive direction. And so when we put it in our calculator, we have a number of different ways. You can actually do this a couple times. You can take and actually do the multiplication in the blue box right away. Or you can actually take the whole thing and put it into your calculator as if it were one problem on the top. And so however you are going to do it, make sure that you're doing the math correctly. A lot of times, this is why students need to show their work, or for me, it is a big deal, showing our work, and so that then we can look at and see, okay, where did something go wrong? It wouldn't be unheard of for a student, because I myself have done it, and that is plug a number into my calculator incorrectly. And so we can then do that multiplication and see that I have 9.109. So that number didn't change. What did change was the scientific notation, and again, how we do it is up to us. You can plug it in your calculator, but you can also see that I'm going to need to move the decimal place 9 times to the right, or make it bigger, and therefore you would add that to it. And so you can also add your scientific notation in that negative 31 plus 9 is going to give you a negative 22 with that. If some of you might inherently already know that based on the math that you're in. However, we just need to make sure we're all on the same board when we come into that. And so what method you use doesn't really matter. It's getting and doing the things that you need to do correctly so that you can get the correct answer. How you get there, though, or the path that you take, doesn't always matter. So a nitrogen molecule has a speed of 0.515 millimeters per second. What is this in kilometers per hour? This is another wonderful step-by-step process where we have some things that we can work on, and we can see that I start with meters, millimeters, and I will need to go to meters, and then I will need to go to kilometers. I'm also going to need to go on the bottom. I'm going to have to go from seconds to minutes to hours. And that's usually the one part that a lot of students forget, is doing that. Both things need to happen at the same time. And we can look at which ones have which, and there should be, there are 1,000 and 1,000. We know that there are 60 seconds and there are 60 minutes in an hour. So that we have those parts done for us. And so we can just then put it in and start with, again, starting with what we're given. This is another reason why I like to write out my conversion factors and my dimension analysis problems like this, and so that we can now choose. Now, do I convert the time first or the distance first? It doesn't matter which one you do first. Some people get hung up on the fact that which one you do first matters. It actually doesn't. I just like to do the distance first. That's my personal preference. That doesn't mean that you have to do it that way. It's just do what you need to do. Now here, a meter is bigger than a millimeter. How many times bigger? Well, it is 1,000 times bigger. Now that we have millimeters rationed out to 1 or equal to done out, I can convert my meters, my new given, to my new want, and then I see that again, kilometers is going to be bigger. How much bigger? 1,000 as well. Now that I have kilometers in the correct place, because it would be kilometers per and seconds right now, I need to now write out my seconds and convert seconds. Now, so far, everything we've wanted to our given is always been goes on the bottom, but for time it has to go on top because it's the per expression. And when we do that, we see that again we have our 60 seconds per 1 minute, and we can now see that our seconds cancel out or ration out to 0. And then we can convert from our new given to our new want, and know that there are 60 minutes per 1 hour, and my minutes then cancel out. And so we now have our correct per expressions, because if I go look here, I can see that I have kilometers per hour is what I do. And then again, we can just plug in these in, multiply across the top, and we do that. Some of us that have been through more than one class might remember the conversion between seconds and hours right away. That's fine. If you know what it is, that's awesome, as long as you're getting the problem correctly and doing it what you're supposed to do. Now, we have some things here. We just can multiply again across the top. I prefer to write it out step by step and give 1,854 kilometers, and then my hour, I need to divide, and so 1,000 by times 1,000. is 1 million. And so now I just do that division. To give me an answer of 0.0018. I'm going to stay with 5. It does end with 4 as well, but we could probably say that 5 is where you would end because of the number of significant digits. My label is kilometers per hour with that. And there you have it. That is the end of the Unit 1. Please make sure that you are currently and staying current on your homework and that you have everything that you need and are preparing yourself for the end of the unit test as we finish items in class.